All right, so the last video was just tangent. How about now just secant? So with secant, we don't, again, have a derivative that gives us just secant. So we've got to add something to it in order to use this. And this one's a little bit trickier. So what we're going to be doing is using this secant theta plus tangent theta. Because if you distribute the top now, you end up with secant squared theta, right? Plus secant theta tangent theta. So this took someone a little bit of time, but I can see their excitement when they figured it out, and you can see them jumping for joy like, I figured it out. I've got an integral for secant. So secant theta plus tangent theta, so we can make that our denominator. So du would be secant theta tangent theta plus secant squared theta d theta, and you can see that's the numerator for this. So this ends up becoming integral of 1 over u du, right? So that is the top right there, so that's our du, and the bottom is u, and so this becomes the natural log of u plus c, which is the natural log of our secant theta plus tangent theta plus c. And now you can go ahead and use that anytime you see just secant theta. You just have to remember it. So the natural log of secant theta plus tangent theta plus c. All right, what about secant squared? You go, okay, what do you do with secant squared? Come on, it's secant squared. That's just tangent theta. And you're done. Moving on. All right, what about secant third to the third? Well, what we're going to do here is break it up. But we don't have, that's not an even secant, because we need that secant squared. So if we do this, right, there's no tangent there that we can create. So what we're going to end up using is a little thing that we've used before. That's right, integration by parts. And again, it's just you try stuff. That's all it really is. So our du is equal to secant theta tangent theta d theta, and our v is equal to tangent theta. That's our integral. So you can see that's why we're using integration by parts. By pulling a secant squared apart, it allows us to integrate it as well. Just like with using u substitution, it becomes our derivative. So works both ways. So now we do our little line across. Remember, it's these two multiplied. So we end up with secant theta tangent theta, and those are done. And then we do the entire bottom. So we end up with secant theta tangent squared theta d theta. And now you go, okay, well, that just looks just as bad. Well, we keep going, all right? So minus secant theta tangent theta. And if we break that apart into our Pythagorean identity of secant squared theta minus 1, you may see something and then you get discouraged like, wait, we're back to where we began? Come on now, that's not fair. But you're supposed to realize that you can do something else when that happens. Once you create that same integral, you can then use it to find the answer. Because we're looking for the integral of secant cubed. So if the integral of secant cubed appears again, then we can solve for it. So we have secant theta tangent theta minus the integral of secant cubed theta d theta plus, because you got to distribute that negative, integral of secant theta d theta. So always be careful there. That minus will go here and here because it's one giant integral. So that becomes a plus. And we already know that one. So we can actually change that one over. And we're going to add this to that side. So if we add the integral of secant cubed theta d theta over here, we just got rid of the one that we were having an issue with. That's a nice thing with math. You always try to get rid of the stuff that's a pain in the butt. So we end up with secant theta tangent theta plus the inner, and you should have known this was a big one. Look how much room I gave it. d theta. Wait, we can just change that one into what it is. What was it again for secant? That's right. It's the natural log of secant theta plus tangent theta. So natural log of secant theta plus tangent theta plus c. And do you see any more integrals? No. Well, the one on the left, but that's the one we're solving for. So the integral of secant cubed d theta is equal to 1/2 secant theta tangent theta plus 1/2 natural log secant theta plus tangent theta plus c. And the reason we're stopping here is we're just going to be applying the same rules again and again. Secant squared you can make into secant squared and secant squared, and so on. Sorry, secant to the fourth you can make into secant squared, or you could do what we did before. So it's the same stuff over again with the tangent. But there you go. So these are all the tricks. You got to make sure that you just keep throwing stuff at it. So plug in a Pythagorean identity. Try integration by parts. Try U substitution. So the videos are giving you little hints on what to do. So if you see this, you can try it. But yeah, it's going to be, you're going to need a note page of all the different stuff that you can try. Just that's what these are.